In this question, they give us an AC circuit with an R, C, and L that are given, and we are given the generator voltage, which is 2.5 sine of 8 pi t. They are asking us to calculate the maximum current in the circuit and the phase angle. I already wrote the expression that we need to use to find I max. It is V gen max over Z. We know V gen max, it's given. It's 2.5. It's from the expression since they gave us the generator voltage. So we need to find Z. So Z for an RLC series circuit, Z is simply square root of R squared plus XL minus XC squared. Now, the question is finding XL and XC first. Now, XL is 2 pi FL, so we need to figure out what 2 pi F is. Again, looking back at the equation that's provided, remembering that the equation is supposed to be Vg of t is Vg max sine of 2 pi ft plus a certain angle if there is an angle. Now the 2 pi f is 8 pi in this case. So my XL is 8 pi times 30 10 to the minus 3. All of this is going to be the units of ohms. XC, same kind of idea, 1 over 2 pi FC, and in this case 1 over 8 pi times 15 10 to the minus 3, and the answer comes out in ohms. Okay, once you calculate all of these and plug them in, remember your R is 2 ohms, we come up with 2.76 ohms. So then I max is just 2.5 volts over 2.76 ohms, which is in this case 0.91 amps or 0.9 amps. The last question is to find the phase angle. Remember the tangent of phi is equal to XL minus XC over R. So we have XL and XC from here. We just plug them in and do the inverse tangent. So we should find phi in this case equal to minus 43 degrees, 43.5 degrees. So it is telling us that the generator in this case is lagging behind the current by 43.5 degrees. In this question, they're asking us for these 4 times, when does V gen is equal to 0? Remember, when we look at them, this is going to be VL, this is VC, and this is VR, and that's V gen. And for the values at any instant, we look for the y component. So the only time V gen has a y component 0 is here. So time 2. When does V gen is equal to VR? Again, we are looking at the vertical component. Vertical component, the only time that V gen vertical component is equal to VR is that one, is that time. For example, here it is higher than VR, Here it does not have a component, and here there is no VR component altogether. So Vgen is equal to VR at time 3. Now, is the phase angle positive or negative? Since Vgen is below VR, it is a negative 1. So it is negative in this case, and Vgen is lagging the current in this particular question. Now, in this particular question, they tell us the statement that the voltage across the generator equals the sum of the voltage across resistor, capacitor, and inductor is true for what? It is true only for the instantaneous values. For the others, we need to use the phasor diagram. So we have a phasor diagram in this particular case, and they are asking us what is the voltage across the resistor at this instant. Is it I max R, I max R of sine phi, or I max R of cosine phi? Remember, we are looking for the vertical component. This is the vertical component since Vgen is along the vertical, so this is the vertical component. So it's going to be VR max, which is this, times cosine of phi for this particular diagram.